In this video, we are going to learn about logarithms. So in the description below, you can click on the link to download the worksheet, which allows you to do the examples together with me, or you can use it as your revision notes before your exams. So let's get started. But before I introduce our friend logarithms, we need to recall our index forms or indices first. So in indices, we learned that there's a function y equals a to the power of x. So a is known as the base, which is the rock at the bottom, and x is the power on the index, which I like to see as a kite attached to the rock. So an example of an index form will be 1000, which is y equals to 10 to the power of 3. 10 times 10 times 10. This is a quick recap. So special index forms that you need to know is a to the power of 1 equals to a, which means that if I have a number, any number, to the power of 1, I will get back the same number. If I have another number, 200, to the power of 1, I'll get back the same number, 200. If I have 1, 3, 4, 2, another random number to the power of 1, I'll get back the same number, 1, 3, 4, 2. So this is a special index form that we need to know. Another special index form we need to know is a to the power of 0 is always equals to 1. So for example, 100 to the power of 0 is 1. 200 to the power of 0 is also 1. 1, 3, 4, 2 to the power of 0 is also 1. So our new friend logarithm, or in short we call it log, is another way of expressing our index form. So in index form, it's a simple y equals a to the power of x. So if we express it in the log form, we will see the word log, L-O-G, with a base a, y equals to x. The base here is the same rock in the index form. The kite has now come out to the front. So in summary, our log form will be log to the base of a, y equals x. For log ay to be defined, or rather, if you want to have an answer in log ay, you need to fulfill two criteria. The first criteria is your y has to be more than 0. And your second criteria is your a, which is the rock, has to be more than 0 and it cannot be 1. So let's look at the example. In index form, we write 1000 equals to 10 to the power of 3. So when we introduce log in, the rock becomes the base to the log. 1000 is my y here, and my kite, my index, is now outside. So if we look at 100, which is equals to 10 square, to write it in log form, we write log first, and then my base is 10, which is the rock. 100 equals to 2, the kite, which is the index. So if you ask me what is log for, log can be used to find the power in an index form. So let's look at some special log forms. So earlier on we saw two special index forms, number 1 here and number 2 here. So if I convert number 1 to log form, it will look like this. Log base a, and I'm logging the a, the same number, equals to 1. So this a came from here, which is the base, and 1 is the kite, the index, right? So which means to say, if I have log base 5 and I log 5, My answer is 1. If these two numbers are the same, my final answer will always be 1. Let's look at the second special index form. A to the power of 0 equals to 1. When I convert it into log form, I have the base here, the rock, okay, the power is 0, so it's here, and my 1. So if I log 1 with any base, for example, it could be maybe 2. As long as I'm logging 1, my answer will be 0. Earlier on, you saw log, L-O-G. But what happens when you see LG? LG is actually short form for log to the base of 10. So earlier on, we saw that 10 squared is equals to 100. If we change to log form, it will be log, log, base 10, 100 equals to 2. Or it can be written as lg 100 equals to 2. So in another example, 10 to the power of 3 is equals to 1000. To change this to log form, it will be log base 10, 1000 equals to 3. So in common log form, or we can rather write it as lg 1000 equals to 3. Another log that we need to know is the natural log. So the natural log is derived from y equals to e to the power of x. So e is the base, which is here, and x is the index, the kite, which is on the outside in the log form. So log base e y is equals to x. So to write it in the natural log form, we will have ln, which is written like that, like a letter L, and n, y is equals to x. So don't be afraid when you see ln y equals to x. It basically means log base e, y equals to x. So we need to know a special ln, a special natural log. So when you see ln e, it actually means log base e, e is equals to 1. So remember earlier on we have a special log. If these two numbers are the same, the final answer will be 1. So here's a summary of the common log form and the natural log form. For common log form, the base is 10. For natural log form, the base is e. Now we'll dive right into 4 questions. The challenging part about log is you have to figure out which formula to use. So I have actually put up the formulas that we need to know. So we are going to identify which formula we should be using for the question. So for question 1a, given that log base 4x is equals to 2 and log base 2y is equals to 3, evaluate x over y. So I need to get out my x from the log form and I need to get out the y from the other log form. So in other words, I will have to change these two logs into the index form. So I'll start with log base 4, x is equals to 2. So this is my base and this is my kite, right? So my base here, my kite on top, will be equals to x. So this is a very easy change to the index form. So as for the other log base 2y equals to 3, same, my base is 2, my index is 3, so I put my base at the bottom, my index, my kite at the top, equals to y. So in other words, my x is equals to 16 and my y is equals to 8. So x over y will be equals to 16 over 8, which is equals to 2. Right, now let's look at another question. Given that log base x a is equals to 1 and log base y b is equals to 2, express xy square in terms of a and b. So I need to know what is xy square. And I have two log forms here. So basically I will need to tease out my x from here, and I'll need to tease out my y from here. So what I have to do is I need to change the log form to index form. So starting with log base x a is equals to 1. My base is the x. My index, my kite is here 1. So base kite is equals to a. So log y base yb is equals to 2. This is my base and this is my kite. So my base, my kite is equals to b. I hope I'm not confusing you by saying base and kite, because actually that's how I look at, or that's how I try to help myself to remember. Another way of looking at the kite is just simply call it the index. So then we have x is equals to a and my y square is equals to b. And this is perfect because the question is asking for xy square. So replacing x with a and replacing y square with b, my final answer will be ab. Now let's look at question 2. Without using a calculator, evaluate this complicated looking fraction. It's not complicated at all after you break it down and realize that we are actually looking at special logs. So 3 log base x plus 2 over 4 minus 2 log base 5, 1, and this whole thing is squared. So we are actually staring at two special logs here. This log here and this log here. If you remember earlier on, we went through two special logs. So if I have log base x, as long as these two are the same numbers, they will get me 1. So the other special log that we went through is also log whatever base I get. As long as I'm logging 1, my answer is always 0. So now let's put this back into the question. Equals 3 log base x will give me 1 plus 2 over 4 minus 2 log base 5, 1, and well, because I'm logging 1, I'll be left with 0. So now I have changed all my log forms to numbers. So on top, 3 plus 2 is 5. Below, 4 minus 0 is 4. And this is squared. So my final answer will be 25 over 16. Question 3. Convert lg x minus y is equals to square root 2 into index form. So this question is testing you on your knowledge of the common log. So when we see lg, it means log base 10. And we are going to log x minus y, which is equals to square root 2. To convert a log form into index form, we must always identify where's the base, our rock, and where's the index, our kite, which is on the outside. So this is our base 10, and our kite, our index is square root 2, is equals to x minus y. So this is the index form. So the thing about log and index form is you need to know how to change them interchangeably. So currently what we are doing now is to change the log form to the index form. When we get the index form, how do we change this to the log form? You must always identify where's the base and where's the index. Where is your rock and where is the kite? So changing back to log form, I have log, my base is 10, my index is on the outside, which is square root 2, and whatever is here will be behind my log. Question 4. Solve log base x 4x minus 3 in bracket equals to 2. So to do this question, we have to change it to the index form first, and we'll slowly tease out the x to find out what is x. So let's change it to the index form first. Log base x 4x minus 3 in bracket is equals to 2. My x is the rock, the base. My 2 is the kite, which is the index. So I'll have x squared is equals to 4x minus 3. Looks like we have a quadratic equation here. So x squared is on the left hand side. I'll keep it on the left hand side. 4x minus 3 is on the right hand side. So to shift it over to the left hand side, I will have to change their signs. So 4x will become minus 4x, and minus 3 will become positive 3 equals to 0. So I will have to factorize this quadratic equation. To get x squared, I'll have both x's here, and to factorize my 3, I'll have 3 and 1. To get negative 4, I'll have to put both signs to be negative. So usually after I factorize my quadratic equation, I will do a quick check. So x times x gives me x squared. X times negative 3 gives me negative 3x. Negative 1 times x gives me negative x. Negative 1 times negative 3 gives me positive 3. So in summary, I have x squared minus 4x plus 3, which means my factorization is correct. So back to solving my x. Then I'll have x minus 1 equals to 0, or x minus 3 equals to 0. So my x is equals to 1, or my x is equals to 3. Now I have two answers here. The thing about log equations is that you have to check whether the answer will be able to define my log base a y. So for my log base a y to be defined, there are two criteria to fulfill. So the first criteria is that my y has to be more than 0, or rather, whatever that I'm logging, it has to be more than 0. The second criteria is that my a, which is the base has to be more than 0, or it cannot be 1. So if my x is equals to 1, my log base x, which is 1, will become 1. 4x minus 3 will become undefined, as the base is 1. So I will have to reject x equals to 1. So my final answer will only be x equals to 3.